As shown in the previous two photos, the drawing that we're using to make this workpiece has the sides labelled A, B, C and D and the two ends labelled E and F. I've marked up the block as shown in the photograph to coincide with the lettering on the drawing. I've also marked out some guidelines, which can be seen in the previous photos also, to help act as a visual guide in machining the two V-shaped slots. The easiest and simplest way to set a workpiece in the vise is to rest it inside of a V-block if you want to have the workpiece set at a 45-degree angle, which is what we've done here as shown in the previous photos. The workpiece is now clamped in the vise, resting on the V-block, and we've also set up a side stop. The side stop is used so that the workpiece can be pushed up against the side stop, which means that when we turn over to complete the second V, if we push the workpiece up against the same stop, the X and Z positions can be used the same as for the first slot. We need to use a different type of cutter for this machining purpose. Previously we were using a face mill, which can only produce a flat face. This side and face cutter, or sometimes called end mill, is also a tungsten carbide tipped with indexable inserts. It has 5 inserts and the diameter is 50 millimeters. It can be used to cut flat faces and also vertical faces, because the cutting edges here are at 90 degrees to the base. I'm going to fit it into the spindle. The cutter is now fitted securely into the spindle. I then need to position the left-hand corner of the cutter so that it's somewhere in the region of where I'm going to be doing the machining. I need to do this by moving the table in X direction, Y direction and also Z direction. I'm going to use the power feeds, which is the simplest way. To do that I have to have the doors closed and the power switched on. So, I now have the workpiece raised so that the area that's going to be cut out is fairly close to the cutting edge of the cutter. I then use the hand controls to position the corner of the cutter so it is almost touching the centre line of the groove. At that point, I'm going to zero the X-axis and the Z-axis. Move the table back in the Y-axis direction until the block is in a position which is clear of the cutter in the Y-axis. At that point, I'll zero the Y-axis readout. Having positioned the cutter in its initial position, I'm then going to move the table 2mm to the right and 2mm up. Then I'm going to take a test cut, which I can then measure and adjust the digital readout to suit. So if I raise the table 2mm, and move the table in the X direction 2mm, and then re-zero both the X and the Z. I now need to set the spindle speed and the feed rate on the Y-axis control. The RPM was previously set at 800 RPM. This cutter is smaller in diameter than the previous one, therefore an appropriate RPM will be approximately 1100 RPM. I also need to check the feed rate on the Y-axis. I'll do that by pushing the lever away from me, which means the table will also move away, and then adjust the feed until it shows 2.0. I'm now ready to take a cut. From the measurements which I took, as shown in the previous photos, with the digital caliper, showing the distances from the edge of the cut which I've just taken to each of the guidelines which are marked on, from this edge to this line and also from this edge to this line, I calculated, as shown in one of the previous photos, the distance which needs to be moved in the X direction and also in the Z direction in order to get the cut to line up with the marked out guidelines. Distance to be moved in the X direction is 3.3mm. Distance to be moved up in the Z direction is 3.03mm. So I'm going to make those two movements now. If you remember, I zeroed both of these readouts when I took the cut. Having moved those two directions, I'm going to once again re-zero the X and the Z. The cutter is now positioned so that the left-hand side of the cutter will be in line with the vertical line, and the bottom of the cutter will be in line with the horizontal line, which is marked. All of that material can't be taken out in one go, however. So, what I need to do is move the table a small amount to the left, 1/4 mm is sufficient, and then I'm going to lower the table to a point where the cutter is clear of the workpiece. At that point, I'm going to use these two locking levers to lock the table in the X direction. I'm then going to take a series of cuts by raising the table in increments until I reach 0 on the Z-axis. First cut which I'm going to take is 8mm above finish line. I'm then going to take a series of cuts 2mm in height at a time until I reach Z0, which means I've got to take a further 4 cuts. One cut at 6mm, another cut at 4mm, third one at 2mm, and the final one at Z0. After having taken the final cut at Z0, 2mm cuts at a time, I'm now going to undo the table locks and move the X-axis to 0. And then I'm going to lock the table locks again. The purpose of the table locks is to prevent any vibration in the X-axis when the cutter is being used. When the cutter is cutting a vertical face, there's more pressure applied on the cutter, so it needs to be kept rigid. So, having done that, I'm going to start the spindle and take the cut by moving the workpiece backwards. This type of milling is Klein milling, and it generally produces a better surface finish than upcut milling. I'll explain the difference between Klein milling and upcut milling in a further video. The two V-shaped slots are symmetrical about the centre line of the workpiece. Therefore, we can just rotate the workpiece around so that the first V slot is at the bottom. And if we place the workpiece into the V block so that it's resting in the V block, push it up against the back face of the vise and then slide it up against the end stop, then tighten the vise. That means that the block is in exactly the same position as it was when it was rotated the other way. This means that we can use the same settings for the X value and the Z value and also the Y value without having to reset any of the X, Y, Z positions. We can use those same ones to produce the second identical V slot. From the measurement